why this topic is so important right now. There's things, I usually like to kick off my talks with just kind of these broader dynamic macro forces that are shaping how things are right now. Operating your plants is always challenging, it's competitive, and it has been and it will be, and it's getting ever harder. But on top of that, we have these new challenges with sustainability demands. And as a result, it's just getting more difficult to get the job done and comply with all the new challenges. So that's been that way for a long time. The big new thing that every single one of our customers is dealing with is, on top of that, you don't have enough skilled workers to do the work that needs to be done. So maintaining the status quo becomes almost impossible. Is anybody experiencing that? Anybody experiencing worker shortages at your plants? 3? Anybody shy? Yeah, I'm just kidding. Everybody is. I know. Literally every customer we serve, every plant we serve is dealing with that. And it's a massive challenge, and it's going to get worse. And then, and you just heard this touched on in the kickoff talks, we've got this kind of silver tsunami, which, by the way, Dr. Carl Hoffhauer is going to be talking at 2 o'clock this afternoon about that topic specifically, the worker shortage. I totally would encourage you to go see that. At the same time, we have this other tsunami of technology coming into the plants. And hypothetically, that's the saving grace that can make this all work. In practice, it's too much too fast, as you just heard described in the session, for many. Now, for some, they're using it very well already. But for many, it's too much too fast, and it's actually creating more confusion and distraction than it is creating benefit. And that's the message that I just really like to share is, there is a better way, and it's not an idea anymore. It's something that's being done now, and it's the way to solve the challenges that are really severe. I do just want to spend a minute more on the challenges and really the why behind we do this, and I just am so passionate about it. So just first a word on the actual problem itself. So we tackle the machine health problem, that space within industry. And the problem is quantified a couple ways. The Department of Energy in the US actually studied this 20 years ago, and it is a hundreds of billions of dollars a year problem in lost productivity due to reactive maintenance on machines. It's actually into the trillions when you include the side consequences. That's how we got our start in this. We were part of a DOE-funded project in 2004 to basically go out and build wireless sensor technology to tackle that problem. And we've been doing it at scale for about 15 years now. And it works, is the short message. But the other thing is it's also kind of personal. I think I look at productivity. My grandfather worked in a factory. He was a union worker at the Westinghouse plant in Mansfield, Ohio. That plant closed in 1990. And if anybody's ever been to Mansfield, Ohio recently, it's a fairly challenged town still. It's a factory town that lost their biggest factory. And there's a really important message there that if we do this right, if we do this care for the machines that are really the workhorses of our factories, we keep the factories there. We keep them operating. We defend ourselves against various forms of competition, and we do it sustainably. So there's just a really important message. The safety aspect of the problem is huge. When OSHA studies injury rates in factories, the biggest category of worker injuries is maintenance workers performing reactive work. So if you eradicate the reactive work, you eradicate a major percentage of the injuries. We've had customers that have done this. They've improved their total recordable incident rate by 10-fold. And then the last one is the sustainability impact. And I think it's a really neat, the reason I'm so passionate about what we do, and I hope a lot of you are, I know some of you in the room are using us very well, the sustainability impact is also really huge because there's more waste coming from industrial machines than there is. For example, if you compare it to the total amount of waste in the transportation, global transportation is responsible for about 8 billion tons of emissions. So even if you switch everything to electric vehicles, the total impact is about 8, and that's a lot. The industrial emissions cumulatively is 36 billion tons of CO2 annually. And the single biggest root cause of a lot of that unnecessary waste is pump systems. Pump systems are the workhorse of the factories in most cases, and they're approximately half as efficient as they should be. I was on the board of directors for the Hydraulic Institute for about 10 years, and they're very well aware of the problem, but just because of a lack of completeness of information and a lack of an approach to proactively tackle the health of the asset and the efficiency of the asset, that problem remains unsolved. So all of those things caused me to just be very passionate about this topic. And I just want to talk some about what we're doing about it and what I would encourage others to do about it, but also just, again, it's not that new for us, just calling attention to what others are doing. So where I like to start here, the biggest thing that I would say we've uncovered, we did a lot of work for the Department of Defense in the first 10 years of our company. So condition monitoring, wireless sensors on Black Hawk submarines and Virginia-class Black Hawk helicopters and Virginia-class submarines, even prosthetic limbs for the Army. And we started uncovering this kind of basic truth. When we started tackling the industrial machine problem, we found it to be the same basic pattern. And the simple way to say it is that the things that cause machines to fail proactively, or the things that cause machines to fail prematurely, can be dealt with proactively because they are unusual. I'll actually tie this to something that Ron Moore said in his kickoff. It's not just about predicting a failure. In fact, we like to use the word going beyond predictive. It's all these other things, these stoppages of production and the operational impacts on machines that cause machines to fail and cause disruptions and all these secondary consequences. I completely agree with his message that that's where most of the problem lies. And here's why. So this is backed by 10, 15 years of data. Most of the things that prematurely damage and cause machines to fail are unusual. By unusual, I mean, an engineer designs a machine, designs a system, designs a plan, and they usually do a good job. They're professional engineers. You lay out a plan for how the system is going to work. Unfortunately, first of all, they don't do it perfectly. No one's perfect, but that's not the root cause of the problem. The root cause of the problem falls in three big categories. The first one is operating condition. It's impossible to properly deal with all of the potential changes in the way systems are going to behave over time. For example, you get things like cavitation in pumps and resonance on structures. It's simply not possible to plan for and model all of those possible behaviors that come from the operating condition. And even if it were, it's definitely not possible. How many people's factories are doing the exact same thing today that they were designed for when they were designed? Anybody in that situation? No. The plants change. Production levels go up, usually. Sometimes they go down. Also a problem. The demands on those machines change over time, and as a result, the condition changes, and as a result, the health of the asset is degraded. The second category, usually the biggest category when we study this in our data, is care. And this is just, maintenance. But it's improperly performed maintenance. Unfortunately, the biggest category of this is just improper lubrication, and even over-lubrication, poorly performed lubrication, but also balance and alignment, all these things. We measure these things all day, every day, and that is a massive root cause. It has nothing to do with the design of the system and the machine itself. It's the care. And the third big category is the configuration. Configuration, again, the biggest category that we see for this is pump systems. Pump systems are a huge amount of the consumption, the biggest category by asset of electricity consumption in factories. It is very rare to see a perfectly configured pump system. I'm not going to say it's never happened, but it's very rare. And a lot of times it's just the challenges of building a system into a constrained environment. More often it's just there's 3 to 5 different groups involved in the design and specification of a pump system. The single biggest reason is because they're simply over-designed due to factor of safety. But as a result, they run way off their best efficiency curve. And when they run off their best efficiency curve, they're not only inefficient, they also vibrate excessively, and they wear out the pump seals and the bearings prematurely. All of these categories are huge. And the other interesting thing is when we study this, increasingly we're bringing the data forward to study these things across different industries and different asset classes. And when you look, for example, in the mining industry, it's a similar general trend. About 80% of the degrading issues are coming from unusual things, but the condition in a mining site is higher. You're outside. I was just visited an aggregate mine in Indiana a couple weeks ago, and it's challenging. You're dealing with the weather. You're dealing with the dust. Everything's moving every day. So the operating condition tends to play a bigger part there. In contrast, when you go to a wastewater plant, I'm going to come join the DC Water presentation this afternoon, your unknowns, the operating conditions are pretty predictable. one of the more predictable types of operating situations. But the configuration of the systems, often just because the scale of wastewater and water utilities is so large, those imperfections that come from the configuration of the pump systems and the blowers and the screens, there's more imperfections there. And so what's important is to just understand where these root causes of the issues are coming from and then have an approach that deals with them as proactively as possible. So that's kind of the how of what I want to talk about next, and it's really pretty simple. We have a rising leader who talked about this, just quantified it very articulately a few years ago, and we just keep repeating it. It's simply a matter of getting the right data, doing the right analysis, and taking the right action. And so again, if you know what Ron Moore was talking about, where the problems are actually coming from, most of the problems, I will tell you, are actually relatively straightforward to deal with, but if and only if you get the right data, do the right analysis, and take the right action. So I just want to spend the rest of my time going through some real-world examples of how this is done. So starting with the right data, and this was touched on again in the kickoff. It might have been Dave Reiber, who we were working with General Motors way back when he was there. He was actually part of helping us get our start with General Motors, and it all starts with having the right data. If you don't have the right data coming into your system, you're simply not going to have the right tool. The insight is really what comes from the data. You're not going to have the right insight that causes you to be able to have success. And so I'm going to talk just for a minute specifically. Our main world is vibration monitoring. So vibration and temperature monitoring with wireless sensors. It's beyond that, but that's kind of the main thing. And a lot of people who aren't deep in vibration think of vibration sensors as being equal, and that's very much not the case. So this is the first point I want to make. When you're looking at vibration that's going to give you pervasive condition monitoring capability, it's very important that it be able to proactively deal with all of the root causes, all of these 80% of things that are going to murder your machines prematurely. If you have just a basic sensor, which, a vibration sensor that measures a scalar value or measures infrequently, say, once an hour, once a day, it's a valuable tool. You will catch certain things, basic lubrication, late-stage bearing faults, and unbalance, just to name a couple. But you'll miss lots and lots of other things. That's really the point when you're looking at the right data for a vibration, condition monitoring solution. If you want to be able to get your modal electrical faults, your cracked and broken parts, your valve faults, your deadheading pumps, your cavitation, resonance issues, you need to be taking high-fidelity data so you actually see the features of all of those behaviors. And you also need to be taking that data often enough so you're seeing when those process changes or those maintenance changes or behavioral changes happen so that you can learn from them and address them. And if you don't have that right data, you're simply never going to be able to notice and therefore attack the root causes of the problems. Does that make sense? Good. I hope so. So here's an example. Just one trend. I'm not going to have a whole lot of data in my presentation, but just one trend of why this matters so much. If this is just a real example from a machine, this is the trend, and each one of those measurements is representing a 4,000 point sample, like a burst of high fidelity data that has the spectrum and all the behaviors within it. But if you just take a step back and look at the trend, what you see, very common pattern, over a period of a couple of weeks, it's running fairly steady, something happens and it goes up and it reaches a point of failure. Okay, great, we caught it, it's predictive, and it didn't cause a huge downtime consequence, and we saved the day. That would be predictive maintenance, and that's sort of described as the ideal. We do not see that as the ideal. The ideal is to be able to go back and look at what happened and see what was that asset doing when it was healthy. More importantly, what was happening when the degradation started to rise? What were all the other factors that might have been causing that to happen? When did it happen? What were the behaviors so you can understand and learn from it and eradicate it from happening in the future? That's the win. Ultimately, when maintenance is performed, first of all, can we confirm that maintenance was done correctly? But frequently, can we notice when maintenance is not performed correctly? I'm going to give you an example of that, which is, again, one of the most common things that happens. So that's just generally what happens. That's why this proactive approach with the right data is needed. And one way we look at this is we just, one of the things we started tracking and noticing a number of years ago is where this problem lies from an asset criticality and an asset type standpoint. And basically, there have been solutions deployed on the most critical assets for decades and decades and decades. I think Don Bentley, Nevada really is what started this movement and tackling the most critical assets. Same thing on aircraft engines. For decades, there have been sensors monitoring the condition of aircraft engines. It's really quite mature. What's been harder is to go after what I call the magic middle, but it's really the balance of plant, the middle, the assets that are very critical, but are so widespread and sometimes difficult to reach, varying in their behavior. It's been historically difficult to tackle all of those issues. And that's the system that that's the part of the problem that we really tackle the most. There also, as you see, my graph trails off on the left, and that's because I'm graphing ROI opportunity. Of course, the actual asset count goes up higher and higher the lower you get on asset criticality. But there's a value to cost ratio that comes out on each asset. And what I would tell you, what we've found is that the primary focus is on the middle part of this curve. But if you only have a solution for the middle part or the low part of the curve, and you can't address the unusual and complex and critical assets, then you don't have a complete solution. So I want to show a few examples of that. Here's one. So when we go into a lot of plants, there are these intermittent assets and critical assets. People use the term discrete versus continuous manufacturing. I don't think that's a terribly useful categorization because most of the plants that we serve have both. They have lots of assets that are continuous and lots of assets that are discrete. A crane, an overhead gantry crane, is one of the discrete assets. And the simple reality is if you take data using, even everything I just said, if you're taking high fidelity data and doing it frequently, even once a minute, you're still going to have a very unreliable data set. You're not going to have the right data for that machine, and it's going to be a trend line that's not useless, but it's not that useful. What you want is to take data at the exact moment when the crane is performing a repeatable behavior, whether it's hoisting or transversing. And so you take that. So this is what an actual data set from vibration monitoring on an overhead crane in a steel mill that's taking data on a trigger when it's moving. Here's why that matters. You're able to now take an apples to apples comparison over the same asset in the same behavior, even months apart. And what you see, if you look at 3 different data sets, again, this burst of 8,000 points, happening over 3 different times, you can see the actual features of behavior, the features ultimately of failure on that asset, and then you can go deal with them proactively. And the reality is if you don't have the ability to take a trigger on an asset like that, you'll never have the ability to solve that problem. Okay, so that takes us into the analysis part. So all of that is, you have all the right data flowing, that's great. How many people need more data? None. Nobody needs more data. What you need is more insights and more actionable information so you can go solve problems. That's really the next main focus. And so I show here just a screenshot of the traditional approach. And when I say traditional approach, I say if we go back 5, 10 years ago, we were building these tools already, trend lines coming from all these balance of plant assets, and analysts can go look at those trend lines and go sniff for problems. That of course, is not the real traditional approach. The real traditional approach before that was routes and PDM technicians going out to acquire the data once a month, once a quarter. And of course, before that were people using their stethoscopes and wooden-handled screwdrivers to go listen to the machine. And even before that, just going around listening to things. So this is just something that's been happening ever since the first industrial revolution. This is what it looked like until fairly recently. And it was a pretty major impact. What's happening now, this is the part where I want to talk about AI. And I love the way that Dave Reiber talked about AI and in a couple ways. And this is, I agree with what he said. It's affecting everything. But it's not affecting everything in the same way. And it's not changing everything in a fundamental way either. Here's what I would say it is doing. By the way, so something I like to talk about is that AI is not new. Most people that are in the engineering world, I think, say the same thing. AI is not new. It's something that's been going on and talked about for a long time. My PhD in the Center for Acoustics and Vibration, which is mechanical engineering at Penn State University, was applying feature extraction, machine learning techniques to optimize complex applications. It was funded by DARPA. It was all submarine applications, very just complex problems. And we were applying this same basic framework that ever since. And what it is it looks like this. First of all, you do have to generate a large amount of data. The data is really the fuel that makes the AI flywheel run in all cases. Our systems are taking in 1.2 billion full fidelity data sets every single month. So just to quantify that, since the beginning of the session this morning, when Terrence started talking, to now, it's about 1 million measurements have happened. And so if you imagine trying to do that with routes, it's just not possible. So it's a massive influx of data that allows you to run a much more powerful loop. The second step is simply to extract the features that indicate the root causes of the problems that you're trying to eradicate. So all those things I listed on the right data slide, we know what those things look like. It's not an unknown. It's not a big data problem. It's an engineering problem. And we know, we have posters. We work with Mobius and the other consulting companies. The features are well understood. And so we just simply need to extract those features and the ones that are yet to be identified and understand what they are. And then it's simply a matter of having a training classifier that automatically notices when those features happen. That's really the AI loop. And then bringing that feedback so that the action is taken and the improvement of that root cause is actually occurs, validating that. And then feeding that information back so you continue to get smarter and smarter, and you don't just continue predicting the failure of assets again and again. You actually learn and proactively go eradicate the root causes of the assets. That is how AI looks for us. The one thing I will say with this, I agree with something Dave Reiber also said, which is that it's, this is very important, but it's not the most important thing. This can be perfect, but if your culture and your people don't want to go actually turn the wrench, go actually solve the problem, actually improve the configuration of the system, you aren't going to get the results that you want. And so it's this, it doesn't replace anybody, it elevates people, but it encourages them to be motivated to go solve problems. I will say one other thing with this slide is I've been doing AI for 25 years, that's true, but it's also true that there's been a massive wave in the last year or two in new AI capabilities. And it's different, it's not necessarily different, it's just applied differently. The large language models and being able to have conversations with AI also does affect this world. So I don't have a screenshot in here, but I'll just describe it. What we've done, one of the things we've done to harness that capability is use a ChatGPT type functionality and trained our software on all of our internal knowledge about all the things I talked about. Cavitation, resonance, bearings, behaviors of different machines, compressors, pumps, fans. All of that knowledge is very accessible, and it's actually now very powerfully, the capability to capture it is very powerful. So when you capture all that, what you can build is a ChatGPT functionality into the software, so you can ask, why is my pump cavitating? What are the typical root causes of cavitation on a pump? And you get a very accurate answer, and you can get as specific as you want, and that's going to continue to get smarter and smarter and smarter in parallel to this engineering feature, AI loop. Okay. So that's a lot about how the analysis is done. I just want to give a couple examples of, again, it's great to do the analysis, but having AI that flags issues is really not going to accomplish anything. You need the workers to actually believe in it and go take action. So just a couple quick examples on what that looks like. So here's an example, a couple things I want to point out here. Does anybody notice anything about this trend? I'd say there's at least 3 things in the trend that are important.
Looks like it cut off and then had some maintenance done or something.
Yeah.
Back up, and now it has its worst problem.
Yeah. Yes, I mean, so we might not know yet what the problem is, but it could have been that. Easily could have been that. In this case, it wasn't. But yeah, so the little blip when it's off, it was down for maintenance. They changed the coupling. And it's shown on the next slide, but that's what they did. But also at the very beginning, you see that the peak when it started up before all this happened. That's a hard start type issue, probably. Is it likely that that's the first time that happened? Probably not. Is it possible that degraded the health of the coupling over time because it happened again and again and again and again for the last 10 years? Yes, very likely. And then, of course, the interesting part, if you're just doing predictive maintenance, is, okay, now it's in the alarm state, let's go deal with it. And all of those things are important. That predictive maintenance is important. We do have to deal with that issue. We also have to learn from it. And here's how. The most important thing I would say, AI and the data acquisition, none of these things are possible without those things. But until you actually have a communication with the right people who can actually take action, you don't accomplish anything. What we've found is we built a capability into the software about 2 years ago. We call it the desk, and what it really is a collaboration tool. It's a conversation about the health of that asset. And that's what's happening here. You've got a remote, whether that subject matter expert who understands what a coupling failure looks like, whether they're looking at it remotely or on site or actually down on the factory floor, it can be all of those things simultaneously, and it leads to a conversation about how to confirm and decide what to do about that asset. I will say here's what it looks like. So again, it is important in many cases to have the high-fidelity tools that allow you to be accurate. One of the worst things you can do is provide too many false positives to your team. And if you do that, you're going to lose confidence in the program and you're not going to get the change that you're seeking. So there's this balance of providing just kind of the Goldilocks amount of information so that your team actually becomes confident and tackles problems proactively. That frequently requires doing things like waterfall plots, showing the trend over time, correlating with other issues, other sources of data. And ultimately, what it results in is confirmation of the issue, improvement of the health of that issue. In this case, it turns out that the improper maintenance was the coupling wasn't installed correctly. They went back, installed it correctly, did a proper alignment job, and you confirm that the asset is healthy. That's how you eradicate the root causes of all of these issues. I'll say just one quick word on this slide. You don't have to read all the details unless you have great vision, but one way we think about this is it's the tools, again, are kind of like a co-pilot. That's not like a brand word, but just it is a guide that helps your team elevate and use these tools effectively. And one question is, how much do you need to rely on others to help you with that change? And so we have a spectrum of this. We have some customers who use this. There's folks from Georgia Pacific here in the room. David, if you want to talk to him, he's doing this in a very mature way. They have a very mature organization that's using this and has a lot of capability internally. So they just really need the tools and the software and the data flows to make it work. At the other end of the spectrum, there are companies that simply don't have that capability. We have a whole set of subject matter experts and analysts that provide that full, we call it Sentry services, that helps you in your journey and even pulls you on your journey when necessary. Like most things, kind of like the asset criticality curve, the most common sweet spot is in the middle. And what we find is that when customers are just using what we call the Desk Plus, that desk capability, but with just a kind of a moderate amount of external oversight, it helps your teams become confident and make sure that they're actually using the data flows, make sure that people are keeping up with their peers at other locations, and that's what we find works the best. And it's just a matter, the results are backed up by real data. When you do this, when you have somebody kind of helping you, coaching you, it's like training wheels, you get maybe 30% more documented value. The biggest thing is you just have more actions. You're actually calling out proactively because of these subject matter experts. You're getting 6.5 times more insights to go tackle rather than just having more data flowing. Okay. So just a couple things to wrap up on here, and then I'll leave some time for questions. Again, it's all about getting the right data, doing the right analysis, and taking the right action. And there are companies doing this at massive scale already. Most companies are not doing it, and that's what makes the time and place that we're in so interesting, especially when you consider the implications and really the workforce-driven need for this. As a result, one of the things I see us as a technology provider, what do we have to do to be kind of a helpful part of the solution? All the things I talked about, have been guided and shaped by our customers asking for what they need. By the way, one of them is also sitting here. Brian Sconey was using our technology at a paper plant back 12 years ago, maybe, who really got us going on this. And we built the tools to enable workers to go solve problems in this way. We also need to recognize, though, that there's lots of other things out there. There's a lot of legacy systems, there's legacy software. There are other new technologies like the Boston Dynamics Spot that we just saw this morning. And so I'm just going to show 2 quick examples of other things that we work with to basically be an interactive part of the ecosystem, which I would tell you from our experience is really important because you can't rely on 20 different providers that are each doing different things. So for example, we've just actually enabled a link between FLIR infrared images into our software. So when you have a team that's going out creating these desk tickets, you've got a mobile app, you've got an analyst identifying the issue, confirming the AI, you've got a person on the floor, you can now take an infrared image and embed that directly in the desk ticket. So in your conversation, there is now an infrared image that supports the troubleshooting of that problem. And in fact, where this is going is you can then actually create trendable points that are trackable over a long time. Ultimately, you can do all your thermal routes this way, but in the near term, it just increases the capability and makes these technologies from other vendors more unified. So working with FLIR on that, that's actually just hitting the streets right now. The other one we've been working on a little bit longer and already have a lot of customers doing this successfully is integration with your CMMS is a frequent thing that's asked for in terms of interfacing with legacy systems. Maximo is the most common among our customers, but we work with quite a few other companies. And the key thing here, the key thing that's asked for is basically to be able to create a work order directly out of this desk. So you have the AI, you have the analysis, you confirm you want to take action, you can schedule a work order from a button right in the app. And that's just simply a matter of, the only challenging part is mapping your assets from the condition monitoring software to your CMMS maintenance software. It's not that difficult. And in fact, you then have the ability to create a work order. What I would tell you is, that's not the most valuable thing. That's the most frequently asked for thing. What actually is valuable, is more valuable than that, is being able to go back and confirm successfully performed maintenance. So having a bidirectional integration so that the condition monitoring software knows when maintenance was performed, and so you have a higher confidence of noticing that coupling was improperly installed. So just a quick word on results. Here's what I think is just the simplest, this is a very simple graph, but this is statistically supported by we have dozens of customers that have done this at full scale already. Some of them are in the room, I pointed them out, you can talk to them about the results. But what I would say is, this is basically what success looks like, is every company has a certain number of unplanned events on an annual basis. And if you don't do something different, it's either going to be steady, or if you keep getting challenged by the skills gap, it's going to go up. If you do what I just described successfully, it's instead going to go down. And what we find is you can eradicate approximately 80% of all of the root causes that prematurely degrade your machines. So you ultimately can eradicate about 80% of your unplanned events. And everything else goes along with it. Similarly, when Ron was talking about OEE, we agree. We have customers that measure that very accurately. We've seen customers improve their OEE across the whole organization by 10%, at the individual plant level by more than that, which equates to eradicating about 80% of the non-productive parts that are constraining your OEE. And what it looks like, if you just look at that big circle, that's the important message I'd like to convey. Just imagine, over a 5-year period, that's like 50,000 events. This would be for like a mid-size enterprise. 50,000 events that are either going to happen or not happen. Think about the implications if you can cause them to not happen proactively. That's why it's far more important than predictive maintenance. Because if you just catch those issues, you'll never achieve this. You achieve this by proactively attacking the machine health with the right data, the right analysis, and the right action. Here's a couple quotes. Like Georgia Pacific, a lot of folks have recognized that Georgia Pacific has been doing this at great scale. Also Guardian Industries under Koch, both doing this at great scale. Rayonier is one of these other dozens of companies that is using it. Upstream oil and gas companies have been doing this for a decade at full scale. The technology is not the holdup. The culture is often the holdup, but mostly it's just a matter of having the confidence to move forward and adopt these capabilities and scale them. I do have a couple of resources just to point to, and I'll open up for questions. These ones, we just have, I think at an event like IMC, and again, I want to just really give a lot of credit to Terrence and Maura for putting this event on, and not just putting it on, but making it fun and energetic. It wasn't like this 5 years ago, 10 years ago when we were doing this, and it's partly because the technologies are becoming mature and being used. I think it's also because of the urgency especially with the worker shortage. But I don't think it takes somebody to do something in order to make it actually happen. And I just really appreciate being able to be here and give a talk, because I think they do make it fun, and I hope everybody has the same impression. And it just causes us to treat this as more of a fun and important thing than it often is treated as by your organizations. The other thing is, I know people here at IMC come from a lot of different organizations. So this, if you scan this one, this will take you, there's a whole bunch of industry-specific guidelines. Again, like I said, just at the basic level, that pie chart of where the issues come from varies by industry. There's lots of information about the specific assets in specific industries where we've already done a lot of this. There are companies that have done this, they're written about in this one, and you can get those ones if you scan that. And then the other thing, what I would say is even more important than that is we have customers. We have a customer event annually. It started as just a learning thing probably 10, 12 years ago, to come and share when we were just figuring this stuff out in kind of the early 2010s. And it evolved into something where we've had a lot of these, dozens of users, just some of the select ones are shown over here, that have sent some of their top leaders to present about the successes and the challenges that they've had. And as I mentioned, David Bonfanti from Georgia Pacific was one of those speakers a couple years ago, gave a fantastic presentation about what I would safely say is one of the most mature deployments, especially when you include what Guardian Industries is also doing under the Koch Industries enterprise. And the fact that they've taken on so much of this themselves, it's just one of the most mature deployments of proactive machine health optimization that exists. That's a really good one. There's another one from Toyota, because Suzanne Kazunis is now the president of manufacturing at Toyota Texas. And she came up and gave one a couple years ago when she was the vice president there, and actually talks about a lot of the challenges. Toyota has 380,000 employees. They're a great customer of ours, but just the bureaucracy and challenge of scale that comes from being so large is a really big obstacle. And she actually talked a lot about that. I don't imagine anybody has more than 380,000 employees. Unless anybody's here from Walmart or Amazon, maybe. So, but 10,000 is a lot. 3,000 is a lot. She talks about that and just kind of the scales of addressing the culture thing organizationally. Now, interestingly, Toyota has one of the most healthy continuous improvement cultures that there is, but that's what makes it so fascinating. Despite that, it's still the most challenging part. The last one I would call out on this list is CMC. So CMC is a steel manufacturing company. They're kind of right in that. They're like a $10 billion company. They're big, but they're not gigantic. They're quite possibly one of the best users. There's a gentleman named Gareth Taylor who presented at our summit last year. He's actually the man. He's originally from Northeast England, been in the steel industry his whole life, and he's just completely adopting and driving change within CMC by using these technologies. And I would tell you that graph of eradicating 80% of the root causes of issues, this anomaly, defect, failure triangle that's shown here is basically what he talks about in the presentation. And the simple reality is they've eradicated 99% of all the issues. Now, it's not across the whole organization. It's at one plant, but it's the most important. It's probably the most sophisticated micro mill, steel mill in the world. And he talks about that in detail. So anyway, all of those, I would encourage you to check them out and just, again, help be part of the movement to go tackle the machine health problem so we can make all these machines run perfectly. And that's, again, the right way to look at maintenance is we're kind of holding these assets in our hands. We're not waiting for them to fail and hoping that they don't or ignoring them. We're holding them in our hands, running them in a precision state, and optimizing their health so that ideally they last their rated life or forever. So that's all I have. So I'll open it up for any questions if you have some. Any questions? Yes, one brave soul. I think he's bringing a microphone. If you.
Hi. So when you create the work order, how much information are you sending over to the CMMS? Are you sending any data history? What's the event?
That's a great question. Typically not. We're not sending full data history. That's possible. Typically, we're just sending the normal details that would be in a scheduled work order, with the presumption that if somebody who then receives that work order wants to validate any of the other information, they just can come back into the software. Because the softwares are accessible to both parties. It is possible. I mean, I will say we've done it. It's not so much in the CMMS integration, but we have companies that that have worked with other third-party companies. I'll name one. Prescient is a software company that's really focused on building digital twins, and we have customers in oil and gas that are having all of this data flow into the digital twin. So it's not even just the maintenance activities; it's all the control activities and everything else, the visibility. And that's a very rapid. This is upstream oil and gas, so drilling rigs. So it's possible to flow the data, but usually it's just the work order itself. Yeah.
Are you sending failure codes, or are the failure codes being analyzed here, or is it just
Failure codes here, the maintenance activity is the one that's going.
and then the resolution is coming back to you?
Yes. Yeah. And that's really important. I mean, again, one of the other things that is important about that is customers usually ask for this so as to make the process of scheduling work orders easier. But because you can actually proactively deal with most of the issues, you simply have less work orders. You're doing less maintenance activities because the root causes of that pump seal failure, the bearing failure, they just aren't happening, and so your number of issues goes down. Any other questions? Stop. The sign said stop. That's a direct order. Well, thank you very much. I appreciate the audience, and thanks.